welcome to today's topic, density and relative density. Talking about density, we can define density as the ratio of mass of a body per unit volume. That means if I talk about density of Sir UD Jesus, it mainly means the mass of UD Jesus and the volume which it occupies. So we'll say that maybe mathematically we can say that density, which conventionally is given as rho, is equal to mass per unit volume. And from here, if we are bringing it down to unit, mass is in kilogram and volume is in meter cube. So the SI unit of density is kilogram per meter cube. From there, we can take it down to relative density. From the word relative, it simply means density of something relative to another. But in the field of physics, we always use water. So we'll say that relative density is the density of a body with respect to that of water. So in definition, we say that relative density is the mass of a given body, the ratio of mass of a given body to the mass of equal volume of water. That means relative density RD can be said to be mass of a body per mass of equal volume of water. That means the first time we talk about density is mass of the body and the volume of the body. But this time we are talking about mass of a body and with respect to mass of equal volume of water. And someone may ask you, what is the dimension or unit of relative density? The up there is mass and the one down is mass. That means kilogram per kilogram, which is 1. So we'll say that the SI unit is unity. It's just 1. It has the dimension, we say it is dimensionless. While the density, the dimension from there, kilogram is in mass, while this one is in length. So we have mass per length cube. This is the dimension of density. But relative density, we say, is dimensionless. And this will bring us to a principle governing density and relative density, which we call Archimedes' principle. Archimedes' principle states that when a body is wholly or partially immersed in a fluid, that it experiences an upthrust. I know you may be wondering what an upthrust is. It simply means a loss in weight. If you have been to the stream before to fetch water, when you pick up your water in the stream, you notice that somehow it's weightless. As you are coming out of the stream, you start noticing the weight of the water. So when you are in a fluid, totally or partially, you experience a loss in weight. That loss in weight is called upthrust. And Archimedes states that when this body, wholly or partially immersed in a fluid, it experiences an upthrust. And that upthrust is equal to the weight of the fluid displaced. So we said, from Archimedes, in explanation of upthrust, we can say that upthrust is equal to the real weight in air minus the apparent weight in fluid. That means if I want to get the upthrust of anybody or anything, I will first check the real weight in space and now check the weight in fluid when it's in water. The subtraction between them gives me the upthrust, and that is the apparent loss in weight. That gives us our upthrust. So in relative density, relating this back to relative density, we obtain a formula which says that relative density is equal to upthrust in fluid over upthrust in water. Upthrust in fluid over upthrust in water. Most especially those of you writing JAMB, watch out for this. A question will come this way, that a solid is dropped in kerosene and again dropped in water. Then it weighs so in kerosene and it weighs so in water. Calculate the relative density. Simply check the upthrust you have in kerosene and the upthrust you have in water and use this formula and your answer will come out. Okay. We talk about another law which we also derive from density and relative density, which is the law of flotation. Someone may ask, as big as the ship is, yet it floats on water, what is happening? We'll say that for a body to float on a fluid, it must displace an equal weight of the body floating. For example, if I have this to be my water and this is a ship or a boat, for this ship to float, it must displace of this water equal weight of this particular ship, and that is what we call the law of flotation. And from law of flotation, we'll get another relative density that has to do with solid, and we'll say that relative density is equal to weight in air over upthrust in water. The weight of a particular thing in air, for example this marker I have, over upthrust in water, can also give us our relative density when you want to calculate the relative density of the solid given. Now, having described density, relative density, and bringing it down through Archimedes' principle to the law of flotation, I would like you also to take a detailed look at this in physics clinic of Fusion, Nigeria. Then, from now, we now know that these are the basic parts that any question or any examination will be interested in. I would now like to take you to a drive into another topic called machine.